Hello and welcome to COP 4708. In this session, we start talking more about implementing the SQL code into constructing the database and processing the commands to view, to create relationship, and create other important reports that needed for the database. Before we move on, so far we learned how to translate the client information and knowledge into a conceptual model, then convert that model into a design with tables, relations, keys, and constraints. We went through an introduction to SQL, and we knew that we will be dealing with either DDL or DML. The DDL is the definition, and the DML is the manipulation language. So that was explained in chapter 2, the data manipulation, some of the commands, while in this chapter we will go through some of the DDL's SQL code. Then we also will use some of the DML commands. Some of the DML commands or statements are select, insert, update, delete, and each one of them, in the description you can see the use of each statement when it's being used. For the DDLs, which is data definition language, it can be used to create a user, a table, a sequence, or index. It can be used to alter, change the definition of either a user, a table, a sequence, or an index. It can be used to delete by using the drop statement, and the drop statement will delete either user, table, sequence, or index. And the last two statements is the grant and revoke, where the grant will grant privileges or permission to a user, and revoke will revoke permission and privileges to a certain user. To understand more, we are going to go through the viewage gallery example, which is stated in the book. You have it in the book, and it has more explanation, more tables. In the viewage gallery, they are talking about a small art gallery that has been in business for the past 30 years. What it does, it sells contemporary European and North American fine art. The viewage has one owner, 3 salespeople, and 2 workers. The viewage owns all of the art that it sells. It holds no items on a consignment basis. The viewage application requirement is to track customers and their artist interests, to record galleries purchases, to record customers' art purchases, to list the artist and works that have appeared in the gallery, to report how fast an artist's works have been sold and at what margin, and to show current inventory in a web page. The database design for the view gallery is shown here, and as you can see, we have 4 main entities: the customer, the transaction, the work, the artist. And the artist with the customer is being connected through associated or associative entity or table that is called customer artist entity, and the ID here, the primary key, is a composite of two IDs, the customer ID and the artist ID. The database design for the artist and work by itself, just those two by itself. The artist, the primary key for that one is the artist ID, which is integer identity of one, and that is the primary key. The name, which is a character of size 25 and not null, that's a constraint. And the nationality is a character of 30 with null can be null. The birth date, integer numeric, and it's for 0 with null. Deceased date, integer numeric for 0, null. For the work ID is the primary key. The title is a character of length 25. Copy is a character of length 8. The description is variable character with length of 1000, since I need more characters to describe the work. And then the artist ID is being used as a foreign key that can connect the artist entity with the work entity. To create that table, we'll use the create table statement to actually establish the structure of that table. So we will call that table artist, and it will be create table artist. As you can see in this side, we have the column name, artist ID, name, nationality, birth date, deceased date. After that, we use the data type. We have to identify the data type. We have the number, the character number, and we can use also a number for the date, whether birth date or deceased date. But also we can use character variable or variable character for the nationality and the name. It depends on how are we going to use it. And then we have the optional constraints, which is the not null and null option that's been added at the end over here. This is just to remind you of the different data types in Oracle: the number, the variable character, the date, the timestamp character, we have the CLOB and BLOB, and we have the n-variable character, we have the binary, and we have the binary float and the binary double. So those are the different data types that can be used in Oracle. For the constraints, we have the primary key is considered one of the constraints. We have the word unique, which also can be used to identify or to be a constraint for one of the columns. And then we have the null, not null, and that's very important to identify the values that need to be filled in, and the optional values that can be left empty. Then we have the foreign key, and then we have the check. To create a relationship between two tables, we use the foreign key as shown over here. So we have the create table artist, and we have the column artist ID, name, nationality, birthday, deceased date, and we have the primary key identified as the artist ID. We have the number with two numbers here, 1 and 1, and that means the first number means the number of digits before the decimal, while the second number is the number of digits after the decimal number. In this case, when we have 35, that means 35 minus 1, and that's 34, and that's 34 digits are allowed before the decimal in this case. while only one decimal digit allowed after the decimal. For the character or variable character, the 25 is the size or length of that character. All what we did, as you can see here, we have the column name, we have the type, we have the optional constraint. All what we did to relate these two tables together is to add the foreign key statement or constraint as artist ID, referencing the main table or the artist table as a reference for the that column. That will make a connection between these two tables. The type of relationship that you might create, one-to-many with relation to parent optional, or one-to-many with relation to parent required. And in this case, you specify the foreign key constraint set foreign key as null, while if it's required, it's not null, it has to be filled with information. The one-to-one relationship parent optional, we specify the foreign key constraint and specify foreign key unique constraint and can be null, while required it will not be null. And there is a causal relationship where we create a foreign key column but do not specify foreign key constraint. If relationship is one-to-one, we specify foreign key as unique. So the different tables that I have, we have the table work, artist, transaction, and the columns we have description within work, nationality within artist, birth date, we have it within artist, deceased date, sales price, and purchase date. The default value is left empty here, but if we have a default value, we can fill it. For the constraints, for the nationality, actually, I have a certain group of nationalities that I'm allowed to pick from, which is the list of nationalities over here. Other nationalities are not allowed, so I have to put nationality condition that has to be in this group, and then I have to make sure that the birth date is not before the deceased date. So you cannot say that he was born in 1920 and died in 1917. Such error will be caught if you have such a constraint. And then you need to have for the birth date 4 digits. 1 or 2 is first digit, and then 0 to 9 for the remaining 3 digits to make sure that you are capturing the year for the 3 digits. For the deceased date also we have the 4 digits. 1 or 2 is the first digit, and 0 to 9 for remaining 3 digits. For the sales price, we have it between only 1,000 and 200,000, so we have a limitation for that one. For the purchase date, it should equal the date, equal or greater than the date acquired. If we need to alter a table or make a change to a table, then I will use the alter statement that will make a change to the structure of that table or the properties or constraints after it has been created. For example, if we say alter table artist and add constraint nationality, where we have to check that the nationality should be in the group of nationalities that I need to specify, which is the Canadian, English, French, German, Mexican, Russian, and Spanish, and the USA. Then I need to add that since it was not created with the original table, I need to add it, and to add it, I need to use the alter statement. The same for altering the artist table to contain a constraint of birth date values to check on the birth date that the birth date is less than the deceased date. We can use also the like to enforce the constraint format, checking on the value of the birth date or birth year to be within a certain format. For example, we cannot say that the first or the beginning of the year or the first digit of the year is 2000 or 3000. I mean 3000 or 4000. It has to be either 1999 or the year 2010, 2008, 2006. So you are allowed to use 1 and 2 in the first digit, while you can change as much as you want for the 3 digits from 0 to 9. We can also alter the table artist to add a constraint for the death year, which will match the same constraint for the birth year to check with the first digit between 1 and 2 and the 3 other digits from 0 to 9. We can alter the table artist to drop constraint if I don't need to validate the death year. So the SQL code, after adding constraints for the artist table, will be mentioning the columns, then adding the first constraint, which is nationality. It will be checked in the group of nationalities that's been provided. The birthday value will be checked within the birthday, and deceased day will be checked to make sure that it's within the range of years or numbers that being provided, and the birth date should be less than the deceased date. Once I run the SQL code in Oracle, I will get this table, which has the columns, data types, and the null. As you can see here, it's not null for the first two, but can be null for the next 4 columns. We don't have any default values, and the primary key is number 1, so we had 1 for artist ID to assume that this is number 1. Now I can alter that table and add a column that we will call my column, which is character 5 and null, so it will be added over here. And I can also drop that column, so you can say drop column and it will drop the column that you just added. We can drop table work, and to do that you have to be careful because if we have constraint that this table is connected to the artist table, it will not be removed and it will give you an error message. Actually, this is good and not good. It's good because it will not allow you to delete any table without taking a permission that the other table is not needing it, and it's not good because if you want to delete, you have to go through the process of deleting the constraint first, then dropping that table. If we need to insert data within that table, then we have to use the insert statement, and it will be insert into, then the table name, then the information that we need to install or insert. At the beginning, we specify the columns in the first line, and then the values that need to be installed in the same order as the columns being specified in the first statement. So insert into artist, the columns are specified here with values specified here. We can also use the update command where we can update artist In this case, the table artist will be updated to set nationality Canadian, where artist ID is 12, and we will change the value of the or the nationality for that cell. We have also the delete command, where we can delete from the table, delete from artist, where artist ID is equal to 14. So we are going to delete 14 ID. Artist number 14 will be deleted from our table. If you omit the word clause, you will delete every row in the table. If you don't specify this condition and say delete from artist, that will delete all columns, all rows. So be careful when you do that. Do not say delete from artist without specifying which line or which record you would like to delete. Otherwise, that will delete all the lines. That will be all for part 1 from chapter 7. We will continue part 2 in the next session. Thank you.